Okay, so in today's lesson, we're going to be looking at Euclidean geometry, ratio and proportion. And the first question that we are going to be looking at is something that I covered in the winter school, and I'm going to go over it very quickly, just for those of you that were not there, and we can move on from there. Okay, so as I said, I'm going to be looking at it quite quickly. Okay, so let's look at that. So this is the first question. Okay, so that was 4.1. And you can see that the levels of the questions are given here in the corner. And there we go. Okay, so in this particular question, and as we discussed with the theorem as well, so remember that with the prop theorem, with the proportionality theorem, for those of you that missed that, if two lines are parallel, for example, in a triangle, so where we have parallel lines, if two lines are parallel, for example, they're giving us PT is parallel to RK, then their corresponding sides are going to be in proportion, which means that VT over TK is going to equal to VP over PR. And that's the prop theorem. And we're going to write the reason as prop theorem. I'll repeat that. If two lines are parallel in a triangle, it divides the sides in the same proportion. For example, VT over TK is going to equal to VP over PR. And this can be found in our notes. And you can quickly, for some of you, you can go over that. There's the prop theorem. I'm going to look at the proof today as well. And there's it here. So going back to the example, so as you can see, how would we structure our solution? It says here in the diagram, and they tell us that triangle VRK has P, VR on T, and VK such that they tell us that PK is parallel to RK. So they're giving us the pair of parallel lines there. VR is 2 units. So this here, we're just going to correct. It's VT is 4 units, as you can see there. So we're going to correct that. And they say PR equals to 9 units, TK equals to 6 units. So let's write that. PR is equal to 9 units. So there's PR. So we're going to write 9 there. And then we've got here TK is 6 units. So that's going to be 6 units. And then VP is 2x minus 10. So this is going to be 2x minus 10. Once again, I'll repeat. If two lines are parallel in a triangle, it divides the sides in the same proportion. And that is ratio and proportion. That's the proportionality theorem. So how are we going to structure this? Watch very carefully. We're going to write out the following. What are they going to ask us here? So if we look at that, so the question here is calculate the value of X. So let's write that down. So we're going to write down our sides in proportion. So we're going to say VP, there's it here, VP over PR. It's going to equal to VT over TK. And we're going to write our reason, prop theorem, that's short, prop theorem. Now you must write the pair of parallel lines. That's very important. PT is parallel to RK. That's important. Now we're going to substitute. So what is VP? VP is 2x minus 10, 2x minus 10, all over 9. That's PR. And then VT is 4. TK is 6. So that's going to be 4 over 6. And now all that's left for us to do is to solve for X. 2x minus 10 equals 2. So I'm going to cross multiply. 9 times 4 is 36 divided by 6. Let's put that in the calculator. So we're going to get 9 times 4. 9 times 4 divided by 6 equals 2. So that's 6. Let's solve for X. 2x equals 2. Take the minus 10 over. That will be 6 plus 10 is 16. Divide both sides by the coefficient of X, which is 2. Therefore, X is going to equal to 16 divided by 2 is 8 units. So there we've got 8 units. And X is equal to 8. So does that answer the question? Let's go back here. Calculate the value of X. X is equal to 8 units. Now, if you want to check your answer, right, you can substitute X equals to 8 here. So it'll be 2 times 8 minus 10, which is going to give you 2 times 8 is 16, and 16 minus 10 is going to be 6, right? So that's equal to 6. You can test now. This is what the prop theorem is all about, right? See, if I have to divide these sides here, Vt over Tk, what's that? 4 over 6. 4 over 6, that's 2 over 3, right? And if I have to divide this now, 6 Vp over Pr, 6 over 9. 6 over 9. I must also get the same proportion, 2 over 3. So the sides are in the same proportion. And that's what the theorem is basically telling us. Now let's look at our next question. So in the next question now, I'm going to be looking at 4.2 once again, and then I'm going to be moving on. So that's we've covered what the prop theorem is all about, and we've also doing the application of it. Okay, so please just read from your textbook and from this notes that I'm giving you. So now we've got our second example that we're looking at. So once again, I'm going to repeat. What is the proportionality theorem? So if we have parallel lines in a triangle, so we've got a pair of parallel lines, and here we've got actually two pairs of parallel lines. What happens is it divides the sides in the same proportion. Okay, so let's have a look here at this particular question. And here they are telling us in the diagram. So let's go and read. In the diagram, triangle ABC has D on AB, F on BC, and E on AC, such that DE is parallel to BC. So they're giving us the pair of parallel lines. They're telling us here that DE is parallel to BC, all right? That's important. We must be given the parallel lines in order to use the prop theorem, proportionality theorem. Then they are telling us, and EF is parallel to AB. So they're also giving us this pair of parallel lines. EF there is going to be parallel to that line there. So AD is 12 units. So AD is 12 units. And then they're telling us that EC is 25 units. So EC is 25 units. Then EF is 20 units. So you are given that EF is 20 units there. So we've got EF is 20 units there. And they're telling us FC is 30 units. So there's FC is 30 units like so. They're telling us that DB is equal to X. There's DB there. And BF is equal to K. There's BF, there is K. AE is 2y plus 3. AE is 2y plus 3. Calculate the values of X, Y, and K. Now, the first thing that we need to take note of here is that if you look carefully, look at our parallel lines there, and we got parallel lines there. Just darken it up a bit. So what does that tell us? If you look here, B, D, E, F is a parallelogram because opposite sides are parallel, okay? So we can conclude here that B, D, E, F, B, D, E, F is a palm. Why? Because we got opposite sides are parallel to each other. Now, what do we know about the properties of a parallelogram? So therefore, we can conclude that X equals to 20, because if BDEF is a palm, BDEF is a palm, then that means now that X is going to be equal to 20, because if that is a palm, we proved it, opposite sides are equal. So therefore, X is going to equal to 20. So we can fill that in there, 20. Okay, always update your diagram. Now, we've got X. Let's see, now we're going to solve for Y. Okay, so we got here 2y plus 3. Okay, we've got AE. Let's write here, because we've got our pair of parallel lines, which is we're looking at parallel lines DE and BC. So we can write this now, AE over EC once again, we are doing this now. AE over EC is going to equal to AD over DB. Okay. So that's exactly what I'm going to be writing down. And the reason for that is because of the prop theorem and because DE is going to be parallel to BC. So let's write that down. So we got AE over EC equals to AD over DB. And then here I'm going to write down my reason, prop theorem. Okay, so once again, remember AE over EC equals to AD over DB, and that is because DE is parallel to BC. So DE is parallel to BC. Now I'm going to substitute. What is AE? AE is 2y plus 3 over EC. EC is 25. Equals to AD. AD is 12. And here now, we know that X is equal to 20, so DB is going to equal to 20. So therefore, 2y plus 3 equals 2. Now, learners, once again, let's cross multiply there. 25 times 12 divided by 20. So we're going to get 25 times 12 all over 20 equals to 15. So we're going to get 2y equals 2. Take the 3 that side. 15 minus 3 is going to be 12. If I divide both sides by the coefficient of y, which is 2, therefore y is going to equals to 6 units. Okay, so y is equal to 6. So we've got x is 20, y is equal to 6. So we solve for y. Now we just got k to solve for. Let's have a look at that. So where is k? K is down here at the bottom. All right, so let's start with this. Let's write. So once again, we've got our pair of parallel lines there, which is AB is parallel to EF. So therefore, we're going to use our prop theorem again. Let's start with the side that we want to solve for. So let's write BF over FC. So this is what I'm going to do. BF over FC. There's my parallel lines there. It's going to equal to AE, and that's going to be over EC. So let's write that down. So it's going to be BF over FC equals to AE. There's AE there over EC. Then we're going to write down prop theorem. Remember, prop theorem is short for proportionality theorem. And always write down the pair of parallel lines. And the pair of parallel lines, there is AB parallel to EF. AB parallel to EF. Now do your substitution. What is BF? BF is K over FC. And FC is 30. Equals to AE. So what is AE? AE is 2y plus 3. So what we can do here is we can write down AE. Now we know that y is equal to 6. So we can substitute here 2 times 6 plus 3, which is equal to 2 times 6 is 12 plus 3 is 15. So we can just simply write down there 15, right? So that'll be 15 all over EC, and EC is 25. There's it there. Okay, there's EC there. Therefore, K equals 2. So we're going to cross multiply there. 30 times 15 over 25. Let's put that in the calculator. That'll be 30 times 15 all over 25 equals to 18. So therefore, K is equal to 18. Right, so that's the first two examples done. Okay, so that's the prop theorem. So learners, it's important for us to make sure that we understand our theory and our application comes after that there. Okay, let's look at our next example. So in our next example now, we're looking at 4.3. In this particular example, you can see what we are given here. Okay, let's have a look. So we have, in the diagram, O is the center of the circle. And it's important for us to take note of that. When the center of the circle is given, then it gives rise to things like angle in semicircle, radii, and so on and so forth. And they're telling us that OM is perpendicular to AC. The radius of the circle is equal to 5 centimeters, and BC is equal to 8 centimeters. Okay, let's read that one more time. In the diagram, O is the center of the circle. There's the center of the circle there. So clearly you can see that AO is going to equals to OB. Okay, that's going to be radii. Then they're telling us that the radius of the circle is equal to 5. So that means we know that that is 5 there, and that is also 5 there. Okay, for our radii. Then they're telling us that OM is perpendicular to AC. So if OM is perpendicular to AC, write that down. Now, what theorem is this? Line drawn from center perpendicular to our chord AC means that it's going to bisect the chord. Excuse me. So we got AM is going to equals to MC. What else do we know here? The diameter is given. So therefore, angle in semicircle, so ACB is going to equal to 90 degrees. And that's going to be angle in semicircle. So it's very important for us to update our diagrams, okay? They're telling us here that BC is equal to 8. So if BC now is equal to 8, learners, if you look carefully, we can now use the theorem of Pythagoras here, and we can solve for the length of AC using the theorem of Pythagoras. So you can do this here, right? I'm sure they'll ask us to do it somewhere along the line. So you say 8 here because, and then we've got 5 plus 5, which is 10 there, right? And remember, AB is our hypotenuse. There's it there, okay? So if we are using Pythagoras now, which we are going to be using, that's AB, the length of AB is 10, so it'll be 10 squared minus 8 squared. Remember, hypotenuse squared minus the other side squared equals to 36. And then the square root of our answer is 6. So that means this whole side here now, AC, is going to equal to 6. So the whole side is 6. And because we know that AM is equal to MC, so that's going to be 3 and 3. Okay, so let's have a look. So what are they asking us to do? It says, so we basically solved the whole diagram, and always say, do as much as you can from what is given here. So that's the most important part. Read that, and always interact with your diagram, okay? Solve as much as you possibly can, all right? Now, the other thing that I take notice of here, if you look at this triangle ABC, and remember, one of the things that we must know when it comes to the prop theorem is our midpoint theorem, right? So the midpoint theorem is very important for us to understand. If you look here, see AO is equal to OB, AM is equal to MC. So if you look here, O is the midpoint of AB and M is the midpoint of AC. What does that mean? It means here that these two lines are going to be parallel to each other. So if they ask us to prove the lines are parallel, OM is parallel to BC. And what else do we know about the midpoint theorem? Also that OM is going to be half the length of BC, so that's going to be 4. right? And that's the midpoint theorem. All right, so let's see, what are they asking us to do here now? Write down the size of BCA. So 4.3.1. So the size of BCA, and that's going to be angle in semicircle, which we already got. So here, BCA equals to 90 degrees, angle in semicircle. Next, 4.3.2a. The length of AM with reasons. The length of AM with reasons. So we already know that AM is 3, but how did we go about doing that? Remember, that was 3 marks there. So let's have a look. So what we did was we're going to find AC here using theorem of Pythagoras. So we're going to say that AC squared is going to equals to 10 squared minus 8 squared. Pythagoras. Therefore, AC is equal to, and we said 10 squared minus 8 squared equals to 36, and then the square root, the answer equals to 6. So AC is 6 centimeters. The units is given in centimeters. Then we can now conclude that AM equal to 3 centimeters, and the reason there will be line drawn from center perpendicular to chord. Okay, so line drawn from center perpendicular to chord. So we are given there. Remember, once again, the radius of the circle is 5. We were given that, so therefore 5 plus 5 is 10 there. And then we are given that BC there is equal to 8. So we use theorem of Pythagoras, and that's important for us to understand. So here, writing AM equals to 3, and the reason line drawn from center perpendicular to chord is very important. Okay, so that will actually be like 2 marks on its own. So that's 4.3.2a, and then now let's look at B. So B says area of triangle AOM, and we must now look at the ratio of these areas to the area of triangle ABC. And look at this level. It's a level 3 question. Let's see, what do they want us to do here? So looking at that, the first thing that we have to look at is, let's look at the area of each triangle, AOM. So AOM, let's use different colors. AOM will be there. AOM. Right. And then let's look at the other triangle. Let's do this one. ABC. ABC will be this triangle here. Now, both of these triangles are right angle triangles. So what we need is basically just to find the area of the triangle, you need the base and the height. So it'll be half base times height. Now, you can find the area of ABC because we have the measurements 8, and we know that AC now is 6. 3 plus 3 is equal to 6. So we can find the area of triangle ABC. But the tricky part here would be to find the area of AOM. So you had to know the midpoint theorem to give the distance or the length of OM as 4 units. Then and only then will you be able to find the area of AOM. That's what makes this a level 3 question. Your knowing and identification of the midpoint theorem. So let's look at that. So we're going to write that down now. So how would you structure your solution? So your solution will be B. First thing that you're going to write is OM equals to half BC. And that's going to be midpoint theorem. And half of BC, as we know that to be BC is equal to 8. So we can just say half of 8, which is equal to 4. So therefore, OM is going to equals to OM is 4 centimeters. Now, we can find the area of triangle AOM. And what's the area? I'll write the formula for you. Half times base times height equals to half times. So the base is, you can use it for either 3 or 4 times 3, right? But it has to be around your 90-degree angle there. So it'll be half times 3 times 4. And that should give us half of 4 is 2 times 3, 6 centimeters squared. So we got here now the triangle AOM, 6 centimeters squared. Now let's go find the area of triangle ABC. So the area of triangle ABC will be half base times height. So we got here 8 times 6. Let's do that. Area of triangle ABC equals to half times 6 times 8. Equals to half times 6 is 3. 3 times 8 is 24 centimeters squared. So now we can write the ratio down because that's exactly what they want. Remember this question, level 3, area of triangle AOM. So now we can write, therefore, area of triangle AOM is to area of triangle ABC. And that will be 6 is to 24. And if we simplify that, we divide by 6. So that'll be 6 goes to 6 one time. 6 goes to 24 4 times. So the ratio will be 1 is to 4. The ratio will be 1 is to 4. Okay, the area of these triangles. So just a quick recap. Don't forget that we needed to identify the midpoint theorem in this triangle here. Okay, by knowing that radii AO equals to OB. And the very important thing that you had to identify, if a line is drawn from the center to the midpoint, not midpoint of the chord, if a line is drawn from the center, I'm talking about this one now, this triangle. If a line is drawn from the center perpendicular to a chord, it bisects the chord. And I think that was the pivotal part of this particular question. So you had to know that if a line is drawn from the center perpendicular to a chord, then it bisects the chord. And that will open up the midpoint theorem for us. Because if you know O is the midpoint of AB, M is the midpoint of AC, therefore OM will be parallel to BC and OM will be half the length of BC. Okay, so let's look at our next question. 4.4. So 4.4, we're looking at following. C. Okay, so in this particular question, right, so we've got a level 4 question here that we need to take note of. Okay, a level 2 and a level 4 question. In the diagram, triangle ABC is constructed such that BC is produced to D. So we got triangle ABC. So there's triangle ABC there, ABC, such that BC is produced to D. So BC is produced to D. DR is drawn with point T on AC and R on BA. CS is drawn. CT is equal to 12 millimeters. TA is 36 millimeters. SR is equal to 20 millimeters. And SA is equal to 80 millimeters. Now let's go make sure we have all of those values in there, right? So what's important for us to take note of here they're giving us all of these values here, and they want us to prove that CS is parallel to TR in the first question. Now, remember that this will here, right, open up for us or give us an opportunity to look at the converse of the proportionality theorem. If we can prove that the sides are in proportion, then the line dividing those sides in the triangle must be parallel to each other. Okay, so just have a look and think about that. Okay, so here we've got, let's put in our measurements. So we've got here CT is equal to 12. Then you got TA is 36. Then we've got SR is 20. And then you've got SA is 80. So SA is 80. So straight away, if they know now, or if they told us that SA is 80, then if that's 20, then that has to be 80 minus 20 is going to be 60 millimeters. So that's something that we must be able to do. Okay. Right. So now we're going to be looking at, let's see, what do we have here? So once again, CT is 12, done. TA is 36, there's it there. SR is 20, that's it. And SA is 80 millimeters. So therefore, that'll be 80 minus 20. So that's going to be RA or AR is 60 millimeters. So now let's go try and prove what do they want us to prove? CS is parallel to TR. So where's CS? CS is here. CS parallel to TR. So if I'm going to prove these two lines are parallel, then I must be able to prove that these sides are in proportion. So let's go and do that. Okay, so the first thing I'm going to do, 4.4.1, is I'm going to write down AR. How did I get it? AR is equal to 80 minus 20, which is going to equals to 60 millimeters, right? Then I'm going to look at proving the sides in proportion. If I can prove the sides are in proportion, then these two lines will be parallel. So CT over TA, let's do that. CT over TA equals 2. And that's going to be 12 over 36. And 12 over 36 equals 2. If you're not, when in doubt, use your calculator. That should be 1 over 3, right? But let's just put it in the calculator just for the sake of it. 12 over 36 equals to 1 over 3. So therefore, CT over TA is 1 over 3. Now let's look at SR over RA. So SR over RA equals to 20 over 60. SR is 20 and RA is 60. So that'll be 20 over 60. And 20 over 60 is also going to give us 1 over 3. Just to double check, 20 over 60 is 1 over 3. So therefore, SR over RA equals to 1 over 3. So what do we notice now? You'll notice that sides are in proportion, therefore the lines must be parallel to each other. So let's see now, how do we write this? How do we conclude this? We're going to say, therefore, question CS parallel to TR. CS parallel to TR. And then our reason will be converse, CONV, prop theorem. Converse of the prop theorem. That's our reason. So we can prove that those two lines are parallel to one another. Okay, so if the sides are in proportion, the line dividing those two sides in a triangle are parallel to each other. So now we can update our diagram that the lines are parallel to one another. Let's answer the next question. 4.4.2. If it is further given that AR is 2 over 3 or 2/3 of RB, BC equals to 2x and CD equals to half x plus 1. Calculate the value of x. 6 marks, level 4 question. Okay, so what do they want us to do here? Let's see. They want us to calculate the value of x. We know that. How are we going to go about doing that? Let's have a look. So the important thing for you to take note of is what do they give you here? Okay, AR is 2/3 of RB. AR is 2/3 of RB. Where's AR? Let's go have a look at that. AR. Okay, let's fill in what we have here. Okay, firstly, BC is 2x. So BC, let's say BC. Let's write that down, and that will be 2x. And CD is half x plus 1. So here you got half x plus 1. And then it says here that AR is 2/3 of RB. Okay, so we've got here, you have to look at that. 1, 2. Now you've got, you can see that it's so important for you to update your diagram because as you can see now, you've got these lines parallel. And you can see I drew the symbols for parallel lines there, okay? So I'm working in this particular triangle now. And if I just highlight the triangle for you, you'll see I'm working in this triangle, which is that one there. Right. So what's important for me to look at now is that if I got that BC over CD, then I must be able to get there BS over SR. Okay, so let's have a look at that. Now, if I'm able to do that. So my first step here is now going to try and find this side over here, which is BS. Okay, so AR is 2/3 of RB. So where's AR? Okay, so there's AR here. And AR, as you can see already, is 60. And then RB, as you can see there, is going to be 20 plus BS. So AR is 60. There's it here. And then RB is going to be 20. Okay, so we stopped at the point where I told you the relationship between AR and RB. If you look at it very carefully, AR we know is 60, and we know that here that RB will be, or rather RB will be 20 plus BS. We'll be able to solve for BS if we apply that. So therefore, remember that they told us that AR is 2/3 of RB. So let's have a look. So 4.4.2, we'll start off our solution as follows. 4.4.2. First thing I'll write is AR equals to 2/3 of RB. So what is AR? That's why it's so important for us to update our diagram. AR is 60 equals to 2/3 of RB. And we said that RB is this side here. The whole of RB is there. And RB is going to be 20 plus BS. So what's my aim? My aim here is to solve for BS, right? So therefore, it's going to be 2/3 of 20 plus BS. So I'm going to write down 20 plus BS. So that's going to be 60 plus. So if I take 2/3 into the brackets, it'll be 2/3 times 20 is going to be 40/3. Plus 2/3 times BS is going to be 2BS/3. So if I put everything now as a fraction, if I multiply by my LCD, which is 3, I'm going to get 3 times 60 is 180 equals to 40 plus. And if I multiply by 3, I'm going to get 2BS there. Let's solve for BS. 2BS is 180 minus 40. Don't forget to mute, guys, please. Right. So there, now we're going to get therefore BS is equal to 140/2, which is going to be 70. So BS is equal to 70. So now we can fill that in on our diagram. BS is 70 there. So if you look at it very carefully now, we can actually solve for X now, right? So we've got to write all the measurements here in our triangle so we can apply our prop theorem. Very important for you to know that the first question, they made us prove that CS is parallel to TR, which we are going to be using in our second question. Okay? And remember, that is very important for this particular question. Okay, let's go for it. So now, in order for us to solve, we're going to say, there we go, DC over CB. So now we can write DC over CB equals 2. And DC over CB is going to equal 2. And that's going to be BS over SB. So that's BS. So no, RS there. RS over SB. So that's going to be RS over SB. And we're going to write down there the prop theorem. And write our pair of parallel lines, which is CS parallel to DR. CS parallel to TR or DR. Correct? This one, there's it here. CS parallel to DR or TR. And there you go. Now let's substitute what we have. DC, what is DC? DC is half X plus 1. All over CB. And CB is 2X. Equals to RS. And here we've got RS, which is 20 over SB is 70. That's going to be 20 over 70. So here we can simplify. You can cancel off the zeros there, right? And then you're going to cross multiply. You're going to get half X. So we're going to get half X times 7, and then we're going to get 2X times 2. So let's go for it. So you're going to get half X plus 1, 7 into that, and 2X times 2, or 2 times 2X. So we're going to get 7. So take 7 into the brackets. That'll be 7 over 2X plus 7. 2 times 2X is 4X. So if I multiply everything by 2, multiply by 2, I'll get 7X plus 14 equals to 8X. And if I now solve, if I bring the 7X over to the right-hand side, 8X minus 7X is X equals to 14. So therefore, X is 14. And one of the things that we can do here now, right? We've got, therefore, X is 14. X is 14. What I would encourage you to do is check your answer by substituting here now. If you had to say half X plus 14, if you had to substitute there, so that's half. I'm talking about like at the end of your paper now. You know, you want to check your answer. Half times 14. You don't want to waste too much of time because you want to answer everything. And that's going to give you 8. Okay, so that will equals to 8 there. And then 2 times 14, that will give us 28. Okay, so if you want to check your answer, what I'm saying is that, see, you can check your sides in proportion there. Okay, so 8 over 28 must equal to 20 over 7. So you can just check using your calculator whether it's correct. So you can say 8 over 28. That's 2 over 7, right? And then 20 over 70 should give us 2 over 7. 20 over 70 equals to 2 over 7. So the sides are in proportion. Remember that these lines are parallel to each other. So our answer makes perfect sense that our value for X is going to be 14. Okay, remember this is a level 4 question. Okay, 6 marks. And that's how we're going to go about doing it. So X equals to 14. Let's move on. Okay, so remember that if we just do a quick break, break up everything we've done. So we've looked at the converse of the prop theorem as well as the prop theorem. Remember that we proved two lines are parallel as well. Okay, so you can try and look at 4.5 on your own. Let's look at the next question that I want to do. So the next question I want to do is 4.7. And there we go. Okay, so in this particular question, 4.7, it says, in triangle ABC, R is a point on AB. S and P are points on AC such that RS is parallel to BP. P is the midpoint of AC, and RC and BP intersects at T. AR over AB is 3 over 5. So we're given AR over AB is 3 over 5. Let's read that one more time. In triangle ABC, R is a point on AB. So R is a point on AB. S and P are points on AC such that RS is parallel to BP. So we got RS parallel to BP. P is the midpoint. So we given that's very important there, midpoint of AC. P is the midpoint of AC. So that means that AP is going to equals to PC. So that's important for us to write down. AP is going to equals to PC. Okay. Next, C and BP intersect at T. AR over AB is equal to 3 over 5. So here we've got AR there over AB is equal to 3 over 5. So if we write AR over AB, so we can call this here AR 3K, and we can call AB 5K. So we will use variables now, okay, to work with ratio and proportion. So AR is 3K and AB is 5K. So if you want to now work out RB, that'll be 5K minus 3K, and that will give us 2K. So that will be 2K there. Okay, so 2K plus 3K will equals to 5K. Okay, so that's one thing that we can do. Now, next, so what are they asking? I say calculate with reasons the following ratios, AS over SC. Okay, so where's AS? So there's AS here, AS over SC. So if you look at that now, you've got the pair of parallel lines there, which is RS, and you've got here, which is SC. So we need to find that, but we know full well that they tell us that P here is the midpoint, okay? So moving forward there, what we can do is, we can say here, because these two lines are parallel, we can call that 3, let's call that 3P, remember? Because if two lines are parallel, it's going to divide the two sides in the same proportion. And it's important for us to use variables and not just leave it as this, right? You can't say that's 3 units, AR is 3 units, therefore AS is going to be 3 units. You have to use a variable, okay? Remember, they're in the same ratio, they don't have the same value. So if that's 3K, now we can call that 3P. And if that's 2K, we can now call that 2P. So we got 3P and we got 2P there. Now don't forget that they told us that P is the midpoint of AC. So if that's the case now, what does it mean? 3P plus 2P. So that means PC is now going to equals to 5, okay? So we can call that 5P if we want to. So we got PC now is going to equals to 5P. So what do you notice, learners? You notice that the whole of SC, right, will equals to 5P plus 2P, which will equals to 7P. Okay, and then we've got AS, which is 3P. So it's important for us to make sure that we understand our theory, and I'm going to go through that one more time. They told us that P is the midpoint of AC, therefore AP equals to PC, okay? And remember that they gave us a pair of parallel lines RS and BP. So if those two lines are parallel, it divides our sides in proportion. That means AR over RB equals to AS over SP. So we call this 3K over 2K because they told us that AR over AB is 3 over 5. So there we wrote 3K over 5K, and then RB must be 2K. So let's structure our solution now. What are we going to do? So AS over SC, so AS over SC. So I think we managed to solve that one. Let's write it down. So we're going to write 4.7.1. So we can write down AR over RB. It's going to equals to 3K over 5K. That was given to us. Therefore, RB is going to equals to 2K. Then next, what did we say? We said AS over SP. AS over SP equals to AR over RB. AR over RB. Because the lines are parallel now, you can write down the prop theorem. And that is because RS is parallel to BP. And what did we call AR over RB? So we said AR over RB, and we call it 3K, and RB is 2K. So therefore, we've got here now AS, and we've got SP. So let's have a look at, we've got PC. So let's write that down. What did we call AS over SP? AS over SP, we called it 3P over 2P. So we know that AS over SP is 3P over 2P. And then we said, therefore, PC is going to equals to. So PC is going to be 5P because we were given that P is the midpoint of AC. And there, let's write that down. P is the midpoint of AC. So what can we conclude? Therefore, AS over SC is going to be, AS is 3P and SC is going to be 5P plus 2P is 7P. So that's 7P now. Okay, that whole thing there. So we can conclude AS over SC it's going to equals to 3P over 7P, which is equals to 3 over 7. So AS over SC is 3 over 7. Okay, so that's our first question done. And what was that? It was 4 marks, eh? Okay. Next one, 4.7.2, RT over TC. So RT over TC, where's RT? There's RT there, and there's TC there. See, this one, we'll just simply say we've got here is here. There's a pair of parallel lines there. So SP over PC must equal to RT over TC. So you've got 7P there. We can call this now another variable, remember? So that will be what? Let's use, so we got KP, let's call that 2T there, and let's call that 5T there, right? Because the sides are in proportion. So therefore, we can say RT over TC. RT over TC must equal to 2T over 5T, which is going to be 2 over 5. Okay, so let's structure our solution. So we're going to say SP over PC, 4.7.2. We're going to say SP over PC equals to RT over TC. And that will be the prop theorem. And that is because RS is perpendicular to BP. And that's now going to equals to 2T over 5T. We can conclude, therefore, SP over PC is going to equals to 2 over 5. So that's RT over TC. Question was RT over TC. Yep, RT over TC. So therefore, RT over TC is going to equals to 2 over 5. Okay, done. Next, what do they want us to do here? They said 4.7.3. They want the area of triangle ARS over the triangle or the area of triangle ABC. The area of triangle ARS over area of triangle ABC. Right, so let's go and see now how we're going to do this. So where's triangle ARS? So we got ARS here. ARS, there's it here. Right, so ARS. Now you'll notice that these are non-right angle triangles, right? So think about how do we find the area of non-right angle triangles, right? We're going to be using the area rule. Remember area rule. What is the area rule of a non-right angle triangle? It's going to be half times the two included sides times, remember, sine of the angle between those two included sides. So think about that for a minute. So area of triangle ARS. So ARS, I put that in yellow. And let's now look at ABC. ABC is, I'm going to do that one in green. Let's just go on the outside there. ABC. Okay. Now, what you want to do in a question like this is, in order to find the areas here, you want to look for a common angle. Okay. And you can see that in both of these triangles, the common angle will be A. The reason that you want to look for a common angle is so that you can cancel them out, because you got here a ratio, or you got them as division. So you can cancel out the sine of A over sine of A. Okay, because remember, these are non-right angle triangles. So look for a common angle. Write that down somewhere. So area of triangle ARS, let's write that down. So 4.7.3. 4.7.3. So we got here triangle ARS over triangle ABC, triangle ABC, which is equals to triangle ARS. And remember, I told you that these are non-right angle triangles, right? So it's important for us to know our rule here for area. It's going to be half times, so ARS. Let's look for the two included sides here, which will be 3K and 3P. So half 3K times 3P. 3K times 3P times sine of the included angle, which is A. Now for ABC, triangle ABC, ABC, you're going to say half times AB. Now, the whole side AB will be 3K plus 2K. 3K plus 2K is going to give us 5K. It's going to be half times 5K times this whole side over here now is going to be 3P plus 7P, or you can say 3P plus 2P plus 5P, which will give us 10P, right? This whole side AC is going to be 10P. So that's going to be 10P times sine A. Remember, area rule for non-right angle triangles is half times your two included sides, right? Your two sides and your included angle. Okay, so half AB times sine A, or half BC times sine A, according to our area rule for non-right angle triangles. Now, learners, we've substituted once again. Go back and check there. So now what can we do? So let's cancel off all our variables which are the same. So we can cancel the half and the half, cancel sine A with sine A, you can cancel that K with K, you can cancel that P there with P, and now all we left with are our numbers, which we're just going to simply put in our calculator. Let's do that. So we got 3 times 3, 3 times 3, all over 5 times 10, 5 times 10. And what will that give us? Equals to 9 over 50. So final answer there, the ratio of our areas will be 9 over 50. So the area of triangle ARS over area of triangle ABC is going to be 9 over 50. So once again, please just go over your area rule, okay, and look at what we did here. So what's the trick there? The trick is to look for a common angle. Okay, look for a common angle. Okay, other things that we have to take note of when we're going to do the proof, and we'll do the proof in our next lesson. So we'll stop there for today.